like this, sideways. So, flexible fiber optic endoscopes made out of rubber, plastic, and polymers and glue. The most difficult spot on the flexible fiber optic endoscope is the distal tip, because it's the only one that's capable of controlled movement. And if you bend things back and forth, they're liable to crack. Water is by far the biggest enemy of all powered surgical instruments, or complex surgical instruments. The ones that we looked at earlier out of metal, they're not complex, they're simple. Well, not much simple about them, but they are. But these are complex, so to speak. Flexible fiber optic endoscopes are just that. Flexible, and they're fiber optic. Fiber optic means that they conduct light from one end to the other and allow them to bend. Before we immerse it in water for cleaning, we have to make sure that it doesn't have leaks. So we provide a leak test before we immerse it in water. So a leak test involves pressurizing the endoscope and making sure that there are no bubbles. The other place where bubbles can leak from are the control knobs at the end, at the business end of the flexible fiber optic endoscope. Okay? So when you move them, inside there we have O-rings, and if the O-ring fails, you will have a leak or bubbles will come out. There's no such thing as a small leak with flexible fiber optic endoscopes. We have 4 channels in the flexible fiber optic endoscope. Operating channel and the biopsy channel, they're the same one. This is where we instrument channel rather, and the biopsy channel. That's the biggest channel of the bunch. The other channel is the video channel, okay, which conducts light signal and video signal back and forth. And the other channel would be a suction channel, and the other one would be air-water channel. Channels need to be dried, and we primarily use alcohol and air to dry them out. Okay, and then of course we use what do you call them? AERs with high-level disinfectants to make sure that we disinfect them. Okay, and we can consider them sterile at some point in time, but they don't have to be, because they come in contact with intact mucous membrane. Because we put in flexible fiber optic endoscopes into naturally occurring body opening, nose, mouth, the rectum. Okay, now on the other spectrum are the rigid scopes, and we can come over here and take a look at them, because there's some examples of them over here. These guys being the rigid scopes. They're also known as telescopes. Okay, a rigid scope, is not made out of the same materials as flexible fiber optic, but it is a scope, and it goes into unnatural body openings. So arthroscopes and laparoscopes and cystoscopes, a lot of times. Cystoscopes can also be flexible, but a lot of times they use these guys here. Now, in order to test these out, we have to look at the lights to see that the light carriers are transmitting all the signals correctly. If there are any black spots in the perimeter, that means something is broken over there. Okay? And we can also read through them. When we move them, we look at the non-reflective sheet with writing on it, and it should be nice and crisp. And we move it back and forth from 3 inches down to 1/4 inch from the page to make sure that this particular instrument can read. If it's fuzzy, don't say that it's broken. First, if the view is fuzzy, take alcohol, clean the optical pieces, the tip and in the ocular, okay, and try to read again. If it's still fuzzy, chances are that there's water invasion and it's just fogged up from start to finish. They're very delicate, fragile instruments, but they can be sterilized. The other complex instruments are powered surgical instruments that use electrical power, batteries, or use pneumatic power, compressed air. We use 3 different types of compressed air: regular ambient air, which is room air, carbon dioxide, and nitrogen. For that, we use hoses to deliver the goods to the powered instrument. Hoses come in a standard 10-foot length. Standard PSI is 100 pounds per square inch in a 10-foot hose. All right, if you add an extra piece of hose, you add, for every foot, 1 extra PSI. So if you have 12 feet, you now have 102 PSI inside your hose. Hoses have to be inspected. And the biggest thing we inspect them for is bleb. Bleb is like a little hernia on the hose that can explode during surgery. We can't have that. Cuts, nicks, leaks, we check the hoses. Hoses can be washed, hoses can be sterilized, and before sterilization, hoses have to be coiled. A loose coil of 9 to 12 inches in size. Make sense? We wash them with mild detergent. We don't use soap because soap leaves a residue. Make sense? If you want to, you can make dummy batteries so you can prevent water invasion. We don't immerse powered surgical instruments in water because water is the number one enemy of the powered surgical instrument. Okay, unfortunately we don't have too much of that stuff here, but at least we're talking about it. Make sense? Well, that's basically it.